All right, so now again, our focus today is really proving the lines parallel. And the first question says, find the value of x. Notice we've got some x's in this problem. So find that value of x that makes line M parallel to line N. So I'm trying to find a way to make these two lines parallel. That's what I want. I don't know that they're parallel right now, though. I'm finding the value. Well, I do kind of know, but I want to know what makes them parallel. That's the whole idea.
And there's really probably only one value. It says find the value, so that means there's only one value of x that will make this work.
Right.
There could be those two lines, that value of x could be anything, but then those two lines wouldn't end up being parallel.
Exactly. So they've given me some measures, and they tell us that angle 1 is 2x plus 1. So I'm going to go ahead and just kind of mark that up there. And angle 2 is 3x minus 5. Now, just starting off, looking at these two pieces of information, all of the theorems and postulates that we looked at today, we had special angle pairs. Are angles 1 and 2 a special angle pair?
You know, they're not. So any of those theorems or postulates would basically, the only way we could use those to like show parallel is if they were a special angle pair. So I do see like other special angle pairs like some vertical angles and linear pairs. And I find vertical angles a little easier to deal with. Angle 2 has a vertical angle right there, and we know that they're going to be the same or congruent, so I can just label that 3x minus 5.
Okay.
And now I have consecutive interior angles, those two right there.
Notice that these two definitely are consecutive interior. So what do you know about them?
Well, to only guarantee that those are parallel, the only way that those can be parallel is if those were supplementary.
Perfect. So because we're trying to find a way to make M parallel to N, we need those to be supplementary for that to happen. Okay, so I can write an equation because I'm solving for an x. What would that equation look like?
2x plus 1 plus 3x minus 5 is equal to 180. And again, we're trying to find what value makes this parallel. And the only way these can be parallel is if those add up to 180. So we get 5x minus 4 equals 180. And then 5x equals 184, and the value of x is 36.8.
And all they asked for was the value of x that makes those lines parallel. Sorry, 36.8. Make sure you can see that dot. So that is the value of x that would make that work. And could we substitute those in and really kind of check?
Check it. We could. Like if I substituted it back in, if I put 2 times the 36.8 and then add 1, that angle 1 is 74.6. And then the consecutive one.
So 3 times our 36.8 and then minus 5
is 105.4. And if I add those together, those do total 180.
Right.
So we did it right.
Yeah, and you can definitely check. That's always a good strategy just to make sure that you've got it right, but definitely. So to be able to find a way to make those lines parallel, we needed to show or make those two consecutive interior angles supplementary.
Exactly.
And guys, if they don't give you the special angle pair right away, look for those special angle pairs. You could talk about linear pairs. You could talk about vertical angles. It won't matter. Those are things that you can assume with just in one intersection. I can't necessarily, though, talk about how consecutive interior angles are. You really want to stick with the one intersection.
Because those vertical angles and linear pairs don't depend on parallel. Those will happen anytime you have two lines that intersect.
Exactly.
So here's another type of example here. The question this time around is saying, are these parallel? So we're trying to figure out, okay, they could be, they could not be. The last one, we said what would make them parallel. This is essentially saying that we don't know if these are parallel or not.
Okay, and I don't see any x's in here, any variables. No. So I know that we've got actual measures.
And we got to explain afterwards. So we're going to, when it's a yes, what would be a good explanation if it was a yes? If I said, yes, these are parallel.
Well, probably some of the theorems would be, like I'm thinking of in a proof, a lot of our reasoning is the theorems and the postulates that we use.
Yeah, they're your support. So if it's a yes, give a theorem or postulate to support your answer. If it's a no, can we use a theorem of that postulate to support it?
Well, let me think, because the theorems and the postulates say, they're a conditional statement saying that when one thing happens, here's what we know, but they don't really say if something doesn't happen.
So then
So
would just
that may need to be more in words.
words. So
Yeah.
when you say no, you have to explain more in words.
So could I maybe just say because these are not, then I don't, yeah. Okay, so I can basically explain using the words of the theorem but putting those nots in there. Almost
Yes,
kind of
exactly.
a little bit of an inverse.
And if
thing.
you wanted to explain the theorem or postulate instead of using the title, that's fine as well. So we'll see maybe some of these to here. Okay, so first things first. When you look at it, you're looking at lines P and Q. Now, in this picture, I see some segments that are intersecting that line. Now, if you need to, you can essentially extend these lines out to kind of, or these segments, I should say, to see an actual line that's intersecting the two lines if you wanted to. Okay. Now, the way to kind of think about it, I'm looking at the fact that all of these things are kind of more on this one. So if you wanted to extend this out to kind of get a visual, that might help. It's up to you.
Okay, so that right there is our transversal we're looking at.
And the reason why I didn't choose this transversal is because there's nothing down here that's labeled, okay? Now, we could maybe go with it, but I like this one because there's more stuff to deal with.
Okay.
All right? So I'm seeing, first of all, I'm looking at these angles, and I see 3 angles that are labeled. When we're talking about proving lines are parallel, we're dealing with 2 angles at a time.
Yeah, we want an angle pair.
Yeah. So
okay, but looking at that, the 48 and the 54, those two, could I use a little angle addition postulate?
we could.
And put those together?
If I add 48 and 54 together, you get a total of
102?
102. So that's using, I'm going to make a little side note, this is using angle addition postulate, which does not depend on parallel. Angle addition postulate strictly is based on 2 angles together, added together, get a larger value.
Okay, but now I see that I've got some consecutive interior angles.
Okay, so this 102 degrees and then the 79 degrees, those 2 values or those 2 angle measures represent consecutive interior angle pair. So
Okay.
what would have to what would have to happen?
I'm
for these
thinking
to be
about
parallel?
the theorem that we learned is that if consecutive interior angles are supplementary, then the lines are parallel.
Okay.
So we really want to see, are they supplementary?
So the question is, are these supplementary, which means we have to add them up, right?
Right, so 79 plus 102, do
Is-
those equal 180? That's the question, do they?
Those equal 181, which is obviously not equal to 180, which is what they should be if this was parallel.
So these are not parallel lines.
So
They're close.
Yeah, so are these parallel? We'd say no or not parallel, however you want to say that. Now, when it's a no, we have to explain in words. So what would be a good explanation here?
Could I say that because the angles are not supplementary?
Now, which angles? Can we be
Okay.
specific?
So maybe we could say because the consecutive interior angles.
Good, I like that better. Because you're just saying the angles, but you got to
Yeah.
be a little more specific. So consecutive interior angles are, you said not
They're
supplementary.
not supplementary. So therefore the
That's
lines
why
are
they're
not parallel.
Yeah, so they're not parallel because consecutive interior angles are not supplementary. Now, I can't use CIAT converse because that would essentially mean that they are parallel because that's what the theorem says.
Okay.
All right, so, and when it says explain in words, guys, that's not...
We're not looking for complete sentences.
No.
We want a complete thought.
Yeah, we
but
don't
not
want
a
to
complete
a paragraph, things like that. The other thing to notice is we did not use the fact that we were hoping these were parallel. So we can't use thinking they are to find other angles.
And I've had kids before take 180 minus the 79 to see if it will equal the 102. And technically, I can't even really do that as my supporting work because then I'm assuming it's going to be 180.
Exactly.
We need to show that those two supplementary angles are that those 2 angles together are not supplementary.
So
we want
I'm going to
show-
stress what Ms. Hogerby said. Basically, we cannot use parallel lines to like conclude anything,
Right.
to find other angles, to decide parallel or not. All right, basically you can't use what we're trying to prove in the actual example.
Right. So really here, what we've stressed with this is show that are those consecutive interior angles, are they, what do they equal when you add them together? That's really the question.
And notice, and I like that she mentioned the showing, you know, I think it's essentially important, Miss Hookery, do you agree that to kind of label, okay, this is the 102 that we're talking about.
Oh, yeah.
And then showing essentially this down here. So we're not just assuming what you're thinking. We want to see what you're thinking.
Exactly.
And then this is support. So if we were grading this on an assignment or a homework or a quiz, we would be, this is kind of your work, okay? And then this is your answer. So you want to have your work along with it.
Okay, now, this next one, look at this picture. We've got a lot of stuff going on.
Oh, man, yeah.
We've got a few sets of lines that we're trying to decide, are they parallel? So looking at this first question, it says, is line AB parallel to line CD? That's the first thing we're looking at. So I'm just going to go ahead and redraw for a second because there's a lot of stuff going on in this picture. And line AB is this line down here. And we've got line CD up here. Or DC, either way. C and AB. And within them, we've got some transversals, right? We've got lots.
Got like 1, 2, 3, 4 different transversals.
So the question is, which transversal would be the most helpful? And for right now, I'm going to just kind of emphasize the lines on my picture too, because I really want to make sure we're looking at this. Looking at this line and this line. We want to determine which transversal we really want to look at. So we need a line, a segment or a line, that is going to have an angle at each of those line AB and line CD, each of an intersection point.
And we want to find a special angle pair that will help you decide parallel on that. So we're looking for maybe corresponding angles, alternate interior angles, alternate exterior, consecutive interior. And I like, and again, look what Mrs. Hookery did. She redrew just those 2 lines off to the side. I think that is such a helpful thing when you have a lot of lines going on. So, okay, so which line or segment? Well, if I look at
line AD first.
I see like an angle 155. I see that 65, but I don't see anything down below.
Nothing's
so I'm
down
not gonna use that one.
Perfect. We'll move to the next one.
If I use this segment that's like goes from D to B, if I do that one, well, there's an angle up there, the 65, and then I also see another angle down there.
Ooh.
That could be useful, so maybe draw that.
Okay. So this is 65 and this is 65 is what we're saying.
Ooh, that is going to help.
Okay, why is that going to help?
Well, because those angles, angle CDB and angle ABD, those are alternate interior angles. And I'm noticing that those are congruent. If alternate interior angles are congruent, then lines are parallel. So yeah, those are going to be parallel. And I know it doesn't say explain, but we might. Let's do it anyway.
Let's do it.
And since it's a yes, I'm going to use AIAT Converse, the actual theorem, because it supports it. If 2 alternate interior angles are congruent, then the lines are parallel.
Perfect. Okay, now we're going to take a look now at another set of lines. And this set of lines that we're looking at is line BC, and I'm just going to go ahead and do it in a different color for right now. Line BC.
Or Ray BC, I guess.
Ray BC, yeah, you're right. And Ray AD. And I'm going to do the same thing. I'm going to mark them on here, but then I'm going to go ahead and just draw that picture in too. So I've got my AD and my BC.
And don't you guys see how much easier, like to me, sometimes when you get a lot of lines and rays and segments, it gets kind of confusing. So I think I know that it's redrawing, it's going to take that extra time, but it's so much easier to see it. So just something to kind of consider.
Absolutely. Okay, so now taking a look at these, and try to, I got rid of the wrong one.
That's okay.
I want to take a look at those helpful lines again, the ones that maybe give me those special angle pairs to look at.
And they have several transversals.
Transversals. So starting with AB, would that be helpful?
No, because there's only one angle.
Exactly. Okay, so starting with, what about DC?
Well, DC, that line DC has a couple angles at each vertex at D and C. So let's draw that. Let's draw that over there. And the 2 angles that I'm looking at are the one at angle, or at point D, there's that 155.
So I'm going to mark it all on here.
Yeah. And there is that 65, but see, that 65 would need another transversal, and we only want one transversal at a time.
Exactly.
So that's not going to help us. And then at the angle, or at point C, 115, which is right up there next to that, And there's a 40, but again, that needs another transversal.
Exactly.
That's going to help us.
All right, what kind of angles are those?
Those are corresponding angles.
And what do you notice?
Well, they're different.
They're different. Are they supposed to be different?
Well, we're trying to decide if they're parallel.
Uh-huh.
So if they are different, then that helps me answer the question. Well, they're not going to be.
Right, because if those lines were parallel, then we know that those corresponding angles would have to be what?
Congruent, but they're not. So we would say no.
But then what would be our reason? Because we can't use a theorem here.
So I'm going to say because corresponding angles are not congruent in this one. And again, when we first learned about corresponding angles and alternate interior angles, all of those were angles based on where they're located within two lines and a transversal, not necessarily parallel.
Right.
Okay, so these are still corresponding angles. They just don't happen to be congruent, and that's okay. That helps us still answer the question.
Okay.
Good. All right, now let's try some proofs. So get your 2 columns set up. By this time, we've done a lot of proofs. We're getting better. But just one thing to keep in mind on all of these. All right, notice where we're trying to go. We're trying to prove lines are parallel. So if we're trying to prove parallel, can we use that in our proof? So could I use A and B being parallel to say something from that?
No. But I know that because I'm trying to prove them parallel, I'm going to be using one of these converse theorems.
Perfect.
So I'm kind of looking at just this picture, and since you've highlighted A and B, I know that I want to get to the point about talking about angle 2 and angle 3, because once I know that those angles are, because they're corresponding, once I know that they're congruent, then I can then state that the lines are parallel. So that's really where I want to go.
So what Ms. Huckgraby's kind of essentially doing is she's kind of thinking backwards.
Right.
You know, sometimes it helps to kind of think, all right, what would I need in order to show lines A and B are parallel? So we would have to show angles 2 and 3 are congruent somehow, right? Can we say angle 2 is congruent to angle 3 right off the bat?
No.
No, because they didn't give you A and B are parallel. So keep that in mind. Kind of think, maybe work backwards a little bit. And if you're working backwards here, our goal, this is our goal is to show angle 2 and angle 3 are congruent. That's our goal. Okay. Now, we can't say that just yet, so that's kind of where we're trying to get to. So all we can use is the given.
Okay.
Right? So let's label what we know. Can I label K as parallel to M?
Absolutely, because that's in our given.
So I'm going to label a parallel, and I could label angle 1 as congruent to angle 2. Now, are angles 1 and angle 2 a special angle pair?
No, they're not. They almost kind of look somewhat corresponding, but they're really not because they're not off the same transversal.
Yeah, exactly.
Okay.
So they're giving you some angles that are not special angle pairs.
And I always seem to have students every year that
You
want to
wanna
say those
that.
are corresponding.
So here's what we need to think about. All right, angle 1 and angle 2, saying they're congruent doesn't really help us that by itself. So let's feed off of this part of the given.
Okay.
If 2 lines are parallel, we know then we have some special angle pairs.
Okay, so I'm kind of just, and I don't know, I like to do this. I like to take, put a finger on each one of those parallels and just look up those parallel lines until I find some special angles on one of my sets of my transversals. So I'm looking at that, and I'm noticing that on line
You go up here. Line B, is that have one at each vertex?
No, it's only got one angle
Yeah,
marked.
and sometimes, guys, the other thing you could do is cover up. We can't do that for you. So a lot of times I just scribble out or redraw it.
Exactly.
Okay, you can take a pencil, you can take paper, whatever. But line B, notice, isn't going to help us with those. So when you scroll up like Ms. Hokery is talking about, line B is not going to help us really. But when you get to line A, it does. And what are you seeing?
Because if K and M are parallel, we know that those angle 1 and angle 3 are corresponding angles. So we know that those are congruent because the lines are parallel.
So angle 1 is going to be congruent to angle 3. And your reason?
Is CAP, corresponding angles postulate.
Now, would I use the converse? Because that's what we've been talking about today.
Well, no, because here I already knew the lines were parallel. And I'm trying to prove those angles, I am proving those angles to be congruent.
So since line K and M are parallel, our angle 1 is congruent to angle 3. I'm going to go ahead and label this with 1 tick mark as well. Now, we've used this given.
I see where we're going.
We haven't used this part. We haven't used step 2. Now, what can I say? Are you seeing something?
Yeah, I do notice that angle 1 is in both of those statements that we have right now. And I feel like we've seen this reason nonstop, it seems. But yeah, I know that transitive property allows me to go ahead and say that angle 2 and angle 3 are now congruent. Because they're both congruent to the exact same angle, they're congruent to each other.
And what's your reason again?
That's the transitive property.
Now,
there's one property we should know by now. I feel like transitive should be it.
But here's something I notice every year with students is that people want to say cap again because they're looking at it and they're like, well, angles 2 and 3 are corresponding angles. So that's the reason. Why wouldn't I use cap?
Because I don't know that those lines are parallel. If I knew A was parallel to B, I wouldn't even need to do this proof.
Exactly. So this came from the fact, like Mrs. Huggerby said, since angles 2 and angle 3 are both congruent to the same angle, we can say that they are congruent because of transitive property. And that's, guys, remember, that was our goal. Our goal was to get to that point. Now that I've gotten there, what does that essentially mean?
Now that means that line A is parallel to line B because, and this is one of those, because we know the corresponding angles are congruent, we knew the lines were parallel, that was the cap converse.
And that's when you need that word converse. So
whenever I'm trying to prove lines to be parallel, I have to have that word converse on there.
Perfect. All right, let's try another proof.
Okay, now this one's dealing with some supplementary. So we're thinking of some, there's only really one that we've talked about, one of these converse theorems that really deals with some supplementary or one special angle pair that we've learned. So be thinking about that. And we're going to start off, we know that line J is parallel to line K and angle 1 and angle 3 are supplementary. So I'm going to go ahead and mark that in my picture. And Mrs. Palermo, just talk to me about what you're thinking right now.
Well, okay, so we can mark the parallel. Again, what I'm thinking, I see, when you see like 4 different lines going on, I see that we're trying to prove G and H are parallel. So I'm going to look kind of backwards again. Okay. So if I just look at lines G and H, that's where I'm trying to go. I look and I notice that they're transversal. There's 2 transversal, but line J is really the only transversal that's going to help us. If I can show angles 1 and 2 are supplementary, because those are consecutive interior angles, then I can prove that G and H are parallel.
Okay, so our goal here is going to be to prove that angle 1 and angle 2 are supplementary. Because like you said, yeah, if the consecutive interior angles are supplementary, then yes, those lines will be parallel. Okay, so that's our goal. That's where we want to get to. Okay, so let's finish marking. We've got that J and K are parallel. I can't really mark supplementary on there.
No.
But let's take a look. 1 and 3 are the ones that they're giving me are supplementary. And we know that whenever there's a vocabulary term in our given information, what do we typically do with that?
We use their definition a lot of times.
Yeah, so what does that tell me?
Okay, so we're going to feed off of angle 1 is supplementary, and angle 1 and angle 3 are supplementary. So by definition, that means they add up to 180. So I could just say the measure of angle 1 plus the measure of angle 3 equals 180, and that's the definition of supplementary.
Perfect. Okay, so we've used that kind of part of our given information. And by having that equation there, that's kind of helpful. We know we want to get to talking about other things to be supplementary. So I can't quite get there yet, but we do know something else in our given. What else do we know?
Well, parallel lines tell us some other special angle pairs. So line J and K, they intersect 2 different lines, but I think the only line that transversal is going to work is G.
Yeah, because if you notice down here,
there's only one angle.
There's not another angle down on this side, yeah.
So I'm looking and I see angles 2 and 3. Those angles are alternate exterior angles, right?
Right.
So I know they're going to be congruent because those were given parallel.
Right, and I'm going to go ahead and unscribble my picture just that way we can have it to refer to later. But yeah, angle 2 and angle 3, because we know these lines J and K are parallel, we do know that those are what?
Congruent.
So angle 2 is congruent to angle 3. And that reason?
AEAT. And it's not the converse because you're given parallel, you're proving something about the angles.
Exactly.
Now, I'm just thinking, because I know this is something I see some students do, could I just put angle 2 into the statement in the given where it says in the given angle 1 and angle 3 are supplementary. Can I just go and say angle 1 and angle 2 are supplementary?
Great question. Can we substitute? What is substitution is a property, right?
And it's a property of equality.
It's a property of equality. Is a statement an equality statement? And is a congruence an equality statement?
No.
No.
So neither one of those. So I can't just replace angle 2 with angle 3 and call angle 1 and angle 2 supplementary.
Right. But that's the whole idea. That is the conceptual thing, but we can't do it without equations.
Okay.
So I'm glad you're seeing
we have equation in step 2. Could I just go ahead and substitute angle 2 into angle 3 there?
Can you substitute congruence into an equality?
No.
All right.
Okay.
So what else do we need to have?
So I need to say angle 2's measure is equal to angle 3's measure. And that's because of definition of congruence. We've done this a few times. That whole typical switching over. Now I can replace and say angle 2 into angle 3. So we're going to put the measure of angle 1 plus the measure of angle 3 is equal to 180. And that's because of substitution. Now that's a good thing. Oh, not angle 2. Did I say angle 2 or angle 3? I meant angle 2. So measure of angle 1 plus the measure of angle 3.
You may have said it. I may have just been.
Who knows?
Who knows?
You guys heard it.
You know. We don't. Okay. All right. 1, 2 is going in its place. So 1 and 2 are then they add to equal 180, which means that they are
supplementary.
So
which is what we wanted to say. So angle 1 and angle 2 are supplementary.
Now, is that what we were trying to prove?
No, but that's our goal to get to our proof.
And what's the reason here?
That's the definition of supplementary.
Uh-huh.
And now that I know that those are supplementary, we know that G is parallel to H because of CIAT converse. CIAT, consecutive interior angle theorem converse, and that's because since consecutive interior angles are supplementary, the lines are parallel.
Perfect.
And notice this proof is a longer one than the last one, and a lot of times it's because you're dealing something about proving with supplementary. A lot of times that means it takes a little bit more steps. All right, last proof, last one. So I see supplementary angles again.
Mm-hmm.
Notice I didn't give you parallel lines in the given either, and you'll notice that they only have 2 sets of lines, J and K, and those are the 2 lines that we're trying to show are parallel. So kind of keeping that in the back of your mind. Let me start writing the given down, and I want to hear your thoughts, ideas.
Okay.
Talk to me here, Miss Gravy.
All right, so I'm just looking at the angles that they give us that are supplementary. And I know angle 1 and angle 5 are supplementary. They're not really a special angle pair. 1 and 4, I'm looking at those, and again, they're not really that much of a special angle pair either in terms of like alternate interior or exterior or anything like that. But I do see 4 and 5, which is where I want to go. I want to get to talking about 4 and 5, and those are alternate interior angles, so I want to be able to get to talking about how those are congruent. If I can say that those are congruent, my goal is to say that those are congruent, because then I can get to talking about J and K being parallel.
So this, once you know this, you will be able to end your proof.
Yeah.
Okay.
So, yeah, looking at the pieces, though, that they do give me that are supplementary, they don't tell me anything about those parallel lines. So I'm guessing that probably that's not what I'm dealing with.
Mm-hmm.
But, I remember, this has been a little while since we've talked about this.
It has been a while.
But I remember when I had 2 supplementary statements, and I had angles that were supplementary to the exact same angle.
And the angles you're talking about are angles 5
and 4 are both supplementary to angle 1. That we did, that was the congruent supplements theorem. And I remember saying that if they were supplementary to the exact same angle, then those angles are congruent.
So I could say angle 4 is congruent to angle 5, essentially?
Yeah.
And
now, I remember, and that reason is congruent supplements theorem. I remember not a lot of my students loved that one because it was a harder one to really take in.
Same here.
So if you see that, you're welcome to use that as a reason here. but I'm guessing not everybody's going to see that.
No. So,
And that's okay.
yeah.
So let's do this proof with that, and then let's do it again without it. How about that?
Sounds good.
So if I knew that, really, then I could step 3 say, then J is parallel to K.
Well, that's kind of convenient.
Yeah, that theorem's nice. It does cut out some steps.
Now,
And the
what's your
reason, because of the alternate interior angle theorem converse. So AIAT converse.
Okay, so let's say you chose not to use that theorem.
Okay.
So because you don't remember it, whatever, either way, there's another way of doing it. So step 2.
So step 2 would have then been probably to define the supplementary.
Yeah, so if you're given a vocab word in a proof, that means usually use the definition. So what would we be able to say?
So I can really make 2 equations. So the measure of angle 1 plus the measure of angle 5 would equal 180. And I could also state that the measure of angle 1 plus the measure of angle 4 would equal 180. And that would be definition of supplementary. Okay, and then I kind of remember seeing these too, where if 2 things are equal to the same value, they both equal to 180, they do equal each other, so I could make one big equation. So the measure of angle 1 plus the measure of angle 5 equals the measure of angle 1 plus the measure of angle 4. So because they both equal the 180, they equal each other. That's a transitive property. When they equal the same thing, they equal each other.
Now, what if someone says, could I use substitution here? What would you say?
Yeah, we could use substitution here.
Yeah.
Put all that stuff in place of the 180.
It's equality again. You
Yeah.
could basically put this in for that.
And I now see that the measure of angle 1 is on both sides of that equation, so I could use SPO to take that away and be left with just the measure of angle 5 equals the measure of angle 4. Again, subtracting that measure of angle 1 from both sides. And now I could say that those would then be congruent.
And is it okay that I have angle 5 is congruent to angle 4? The last one
Sure, and I can't, because that's not my final outcome.
Yeah.
That's not what I'm trying to
Okay.
write.
We're good there.
Yeah.
So I could say their congruent definition of congruence.
And
Then
then
I could say,
that J is parallel to K. Still AIAT converse.
so this one was basically twice as long.
Yeah. So if you remember the theorems, we just said theorems are just shortcuts. They can all be proven. We can do it the long way.
Yeah.
But it is not. If you do remember it, it can save
Oh
you
my
some
gosh,
steps and
it's
they're
nice.
nice.
So
Notice, though, again, that congruent supplements theorem, we had to start off with 2 supplementary statements. Those never prove anything to be supplementary. But with 2 supplementary statements, we can prove those angles to be congruent.